A much better approach is to use a convention that limits direct access to class fields while providing appropriate methods to read and modify data. Such a pattern, known as JavaBeans, means creating objects that meet the specification, which allows convenient use of such objects in the future. According to JavaBeans requirements, direct access to class fields should be possible only inside the given class, which is obtained by using the word private. A pair of access methods should be created for each field, setter and getter, which set the value of the field or allow it to be read accordingly. The class should have at least one public constructor. The names getter and setter are derived from the fact that each field should have a pair of methods named setFieldName and getFieldName that allow to setting or reading values. For example, we have a private field data and we have a getter method, so get and field name, get data, and also a set method, set data. Let's adapt the smartphone class to meet the JavaBeans requirements. Private fields are already there, but we have to generate setters and getters. In order not to write repetitive code, IDE usually has the ability to generate it for us. If you press the Alt Insert key combination, or you select Code menu and next Generate option, a window will appear in which you will be able to choose what you want to generate. In our case, we want to create setters and getters. Then we choose for which fields are to be generated, so I select all of them and click OK. I like also when the code is well structured, so I move the generated methods and put them after the constructor. This structure of classes at this stage may seem to you as overloaded code, but if you get used to it, you will later see that it is necessary when using some of the more advanced tools. For example, in setters we can add additional checking of certain conditions. Suppose you don't want someone to be able to set the amount of memory as a negative value. The setMemory method would then look like this. First of all, we want to check if past memory is greater than 0. If yes, we'll assign, and if not, we'll print some value.